Welcome to the WeeW guys! So in the previous tutorial we worked together to create a Python program to read the data, the serial data from the microcontroller, and we have kind of a dynamic display and easy to read from the terminal. However, in the previous program we still were like jailed in our terminal, plus for the baud rate and which COM we are going to use, we have to set up it within the Python code, which not really a user-friendly or give us enough flexibility. So for this time, let's close this program and take a look to the one that we are going to create. So let me bring everything here. So it will become a GUI or a graphic user interface. So let's bring here. And first of all, this GUI will have the available port. So now as we have connected the UART here, so we do see it here as a COM3, but let's remove it and see what did happen. If I refresh, there's nothing. And then when I add the UART again, or the FTDI, and I refresh, I'm able to choose the connected UART, which is really helpful. We don't need to look and put it in the code directly. After that, we will selecting the baud rate that we are going to connect. So I put it enough baud rate, and you can see now the connect button is selected before that. So now I can click here, but if I go and put refresh, which will generate this one, the connect button is not able to be pushed or disabled. Okay, so we are ready. So let me just refresh the microcontroller just in case and connect. So the output will be a program that will have a kind of graphic display to easily understand where we are, plus the value. That's much more easier, much more friendlier, and we can see together that this is quite smooth and nice to read. So if you like and you are interested to know how in detail this works, and we are going to use Tkinter and also threadings to manage this kind of animations. So stay tuned and let's start. This is a WeeW tutorial, and we are going to learn together how to use Python to create a friendly user serial interface with the microcontroller. Before jumping to the video, let me take the moment and thank everyone for their support. I will keep doing my best to provide this quality content. So as usual, to support the channel, you can give us a thumbs up, make a comment, or subscribe, and stay tuned. As usual, the code that we are going to write is available on GitHub. You can find the link in the description below. We are going to use only Python, and the text editor will be VS Code. Finally, the level here is intermediate for the Python, but if you follow the details and the explanation during the tutorial, you will be just fine and you will understand how the program is working and also the code. For the hardware, we are going to use the STM32 based board, which is the aka blue pill. Also an FTDI FT232, which is needed to establish serial communication between the STM32 and the PC. But if you do have an Arduino, you will not need the FTDI. And also a potentiometer or a variable resistance, which we are going to use to see the dynamic change in the graphic user interface when we are going to make the connection with the STM or the microcontroller in general. Okay, so let's take a look to the tutorial. So first of all, we need to have a quick review on the circuit and the program that we are going to build. Then we are going directly to jump to the code and set up the initial basic graphics for the interface. After that, we have to update the available COMs and baud rate, so we'll have an enriched menu for the user. After that, we set up the serial communication. Finally, a dynamic GUI update, and if needed, some testing and debugging. Okay, so how this circuit is working. First of all, we need a microcontroller. Here I'm using the STM32 We're going to connect the STM32 to the potentiometer. So this is a different tutorial where we created the code inside the STM32 to read the value through the change of the potentiometer, and then connecting the STM32 to the FTDI and generate the communication with the PC. So the message or the UART message sent from the STM32 will be very simple and basic. It will be the value of the voltage measure plus the new line digit or the character. Okay, from program perspective, we will have a first main thread, and the program will be made of threads. The first thread will be managing the GUI and the program logic with the interaction with the user. The second thread will be managing the UART data, so we are going to read the data using the UART communication within that thread. Finally, the third thread, and this is what is new, this is the one that will update the GUI display when we receive the new data and we can see the dynamic change. Okay, that's really great. So now that we do have an idea about the program, but you will see further in the code when we are going to write it. So we can jump and set up the initial basic graphics. Okay, so this is our VS Code. We almost have an empty code, and I added here, so I tried to increase the font as much as possible, and this is the file that we are going to work with, and this is 003 Python serial GUI option graphic. The two previous one are the one that we used for our tutorial, and then we are now going to start with the first step. Okay, so first of all, let's import the Tkinter. So from Tkinter import everything, so we'll put a star. So Tkinter is a core or a standard Python library, so you don't need to download nothing. So we are going to start first of all to define, let's define a function to put everything compact. So connect, we call it connect menu and init. So within this one we are going to set up the early and really basic part of the menu that we will almost stay static or will change a little bit later on. Okay, so let's start with the first one, the root. So we put root, and that will be equal tk. So let's tk with a T capital letter. So this one will initialize on root, and saying that will be our core or the the origin of our GUI or user interface. So after that we will put root here dot title. Let's call it very simple, like serial communication. And after that, let's change a little bit the geometry. I'm doing more this to give you an idea about the flexibility that you do have by playing with the GUI. So here, let's put it 500 by 500 for the moment, and let's see what is the result. Then finally, let's change the color. root.config, and we would like to change the background color, so it will be beige equal white. Okay, so and also, as we are going to use root in many different other functions for later on, let's put global here, and we call it here root. So we are going to use it. No, not somehow. Okay, so after that, just for testing purposes, let's call this function here. Okay, and then we call root main loop, and this is to make the GUI live and not like just showing it and closing. So for people who are really not used to Tkinter, so if I remove this one, let me run here, nothing will happen, because we need a loop that will be running and running and running again until we close the GUI. So now let me uncomment and run here, and this is coming here. So we do have our white page with a serial communication as the title here. So let's close this and continue a little bit. So after setting up the root or the main page or main window that we do have, let's start adding some labels. Okay, so let's call the port label here, sorry. So we are adding some label to the root, so we call it port label here, and to add a label it's quite very simple. It's just label here that's coming from the root library, and it will be under root. The text that we will have, so let's put text and equal available ports. Well, yeah, available ports. Okay, so I put the S between parentheses just in case, and like this. Also, let's keep also the background same exactly as for the root configuration, and we will put white. Okay, I think that's all. So this is declaring the label, but we need to add it like kind of physically to the root window. We have to add this line, so port, and then same, so like we can just copy or almost wrote it all, but anyway. And after that you have to put a grid like this, and after the grid we need to put some option, sorry. So for example, column, I would like to put this one really at the beginning, so column not showing yet, so mn, and equal 1, so I would like it in the first column, row equal 3, so third row, and I'm adding some padding. So padding is a space, so let me do it without padding so you'll see the difference. Okay, there's a mistake somewhere. Column, yeah, this is column equal 1, row equal 3. Okay, let's put here and let me show you. So this is the first result that's shown up, so it's really too near to the border, it's not such pretty to see. So let's before this one, I quite before choosing available port is correct. And okay, so after that let's add here some padding. Let's go add some pad Y, and let's put equal 20, and this is in kind of pixels, and the pad X, and we will see if that's enough or not, equal 10. Okay, so let's save and see the difference now. Much better now. You see there is a little bit of space here, a little bit of space here, and you feel there is more space within this new label. Okay, so let's close. After that, so let's add, so we will have a connection like a bottom that we will need to sorry, first of all we need to refresh oh, before that one also, that's quite my mistake. Let's copy, and you'll see how easy and simple it will be. We need to add another extra label, is the one related not the port but actually about the band, the baud rate, so BD here. And so it's not available port, but it's more about choose the baud rate. So let's put baud rate exactly same. So but instead of putting, so this one will be row 2 and this one will be row 3. So, and if we do exactly the same thing, let's see what will be. So yeah, that's good. So I have to put it also on the grid, and the grid allow us to make the display inside the root. Okay, and this is the picture that we do have. So we do have this baud rate here and like this one. However, in this one I maybe don't need, let's keep it like this and see how it goes. Okay, let's close here, and now we start adding the button. Okay, so let's go with the first button, so the refresh button. Okay, we call refresh btn, which is simple, and to declare or to add a button for the root, it's just button, and this one will be ender root. Okay, and after that, so ender root, the text for the refresh will be very simple, so will be just an R, big R like this, capital letter. And so for the moment we will keep it like this. We will change a little bit the size, so this is something to change the size, so height, let's put equal 2, width equal, width equal 10. This is more aesthetic stuff, but sometimes it's quite needed. You can remove them later on and see how it transformed, but just so the bottom we would like to see it in front of the row number 2 about the available ports, because we would like to refresh and see if we have a new port or not. So we are going to grid it, and we will use the same thing here, only up to here. and let's put, so it will be column 3, so we'd like to put it in a column 3, and row number 2, same as this one. So we should see something in the same row as the root, label for the ports. Let's check. Here we are, and if you see well, we put it like this one, the label in column 1, but the bottom in column 3, but nothing. When we will add later on the option list, we will see that something is coming between them. Okay, so we created this bottom, and finally we need the last bottom to create or generate, which is quite simple. Let's go here and create the connect button. Connect, let's put btn, and that will be equal exactly same like this and like this, but we will change a little bit some parameters. So instead of r, we are going to write connect, and after that, one thing that we would like to have is when we still didn't choose the port and the baud rate, we would like to have a disabled button. So what we will add here, we will add, let's go here and put status or state equal, and between the not parentheses comma disabled here, let's put with a small disabled. I hope I'm writing it correctly. Okay, finally the column should be column 3 as usual, because it will be at the end in the right, but the row will be row number 4. It will not be really pretty for the time being, but after when we add the option menu, that will make more sense. So let's bring here. Okay, we found like there is a mistake here, and it's very easy to find it because I didn't update the connect button. So let's close this one, and if I bring this one here and put it there, let's take a look how the result is now. Yeah, we do have our refresh button and the connect is disabled. Perfect. So now we need to add some stuff here to create the baud rate, just to show you the baud rate because it's quite simple, and then we can jump to the next section. Okay, so let's go to the baud rate and how we generate the menu for it. Okay, so here that's the init menu and it's working well. So let's create another function to not make this one that heavy, and we call it baud select. So def baud select. Okay, and nothing to get in. And what we need to do, so we are going to put let's call, we have to create a menu, but before creating the menu we need to put some data inside this menu. So I already created it, so just a moment. So clicked, let's create, yeah, and this variable have to be inside a certain variable that will keep the track of the menu number. So I will show you immediately how. So let's call it clicked bd. Okay, and this is a special variable related to Tkinter, and it's called string var, and this is where we are going to put the data that will go inside the option menu, and that will track the number selected within the menu. We will see later on how it's very useful. Okay, and let's call PDS. So I already write it, so let me just copy this, and these are the baud rates that will be available for the serial later on. Okay, so we do have from nothing here to 255 to the 256,000. Okay, so we add this one, and what we need to do, we will say clicked here bd is, no, not is, but set here comes, just a moment, here not comes to 0, but it will be the BDS of 0. BDS here, and like this we put 0. Okay, And after that, we need to create a drop menu. So for the BD, so drop here BD, and we call it, so it's an option menu, but the name will be option menu. It will be under root. This is like, that will be within the window of root, and the list of variable will be clicked BD. This is the one that I think I really write it wrong. So this one clicked, I think it's totally wrong here. That's a shame. Yeah, clicked BD. That makes more sense. Okay, let me correct it everywhere before a disaster happen. Here again. Okay, so this is here the variable that will track the selected point, and after that I have to put star BDS and put like this. Okay, so no, sorry, I don't need this one. So after putting that, we can add some configuration. So for example, the drop BD, this is how you configure out of this, so out of the option menu. So if you put drop BD and after that config, and for example you say with, so you can put a lot of option inside here, but that's, why did I put this, DTH, and that will be equal, for example, 20. And after that, like, let's put the grid or the function that will add my menu to the will add the menu to the to the root. So will be column here. I'll put column, yeah, equal. So we would like to have this one with in front of the baud rate, so it will be the row 3. Okay, this one is column 1 and this one, so this one is column 1 row 3, so this one should be column 2 row 3, row equal 3. Okay, and let's add a little bit of padding. Let's call it pad x and equal 50. Good, so let's save, and after that, instead of adding it, I will add it just here. Okay, so let's save again and run the program to see what's happening. Good, so you see here I do have this one now good ready here, and I have my list, which is really fantastic. So let me change a little bit to show you what would happen if I put it in row 2. You see now the selection menu came to the in front of available ports. So let's revert back like this, and also let's change a little bit this one. If I put 5 here, just for you to see what would happen. So my initial menu was with number 5. Okay, good. So this is working perfectly. So then we can add the also the one for updating the COMs. Let's see, I think that will be a little bit heavy. So for this part we can stop here. We already have almost the whole menu, and we can jump to the next part. We just completed the initialization of the most graphics or the basic menu, so now we are going to go for the updating the available COMs and also playing a little bit with the baud rate that we have set up. Okay, so now that's a good timing to start having a little bit of fun and start updating the how many UART connected to our computer. Okay, so let's start and create this function. So we call it dev here, or call it update and COMs. Okay, so no input are needed. And after that, so for this one we need to start getting some special library, and for that you have to download the serial library or the PySerial library, and this is the import that you need to put within your code. So import, and if I remember well, because it's a little bit long, so serial tools, then list, and finally ports, and a bar and ports should be correct. Maybe I'll be wrong, but let's see later on. Okay, so where is the update COM? Here. So this is my function here. So let's put ports is equal serial, the whole thing that we have wrote, so tools, exactly, and after that list. It's exactly the same thing, so just I'll copy this one like this, and after that I have to add COM ports, and this is a function here. Okay, after that, so after reading that, so the list of the COMs that I have is equal, so we are going to take the special port from these ports. So okay, let me print ports just to show you what is inside it. Okay, so let's run here. Okay, so we have our GUI working. Of course it will not be working because I need to add this function to the menu in it. We need to put it anyway with the initialization. Okay, so let's run again. So, and you can see here we do have some data inside this one. So what we can do on this one, so let's get all the data inside it. Okay, so if we do COMs will be equal, and we are going to put COM of 0, so we are going to create a list COM 0 for COM in ports. Okay, so and after that let me print COMs to see what is these COMs. Okay, so before running the program, let me share with you what do we have here. So this is our STM32F1. Let me show you a bigger picture here. So this is the STM32F1 connected to the FTDI, which is connected to the USB. So right now I do have only one connected. So if I go back here and I run my program, I do have COM3, which is here. So we do have a COM3 that is connected. So this is here. I don't know why the window comes in the other window, but okay, so let me now, so if I go there and I remove the UART, okay, so and if I run again, there's nothing. That's an empty one. So you can see here, this is still the window appearing there. So let me put it back again, put this one here again to be sure that everything is going as expected. Okay, and we do see the COM3 is here. So let me close the window. So now we can start working, and let's add, we need to add COMs here, and we'd like to insert, so I'd like to insert at the position 0. I need always to have this one gamma to show that it's no choice. Okay, and after that, as we do have a refresh each time, I will add a try here. Okay, so this time this we are okay, let's remove this one and continue a little bit. So what we would like to create is clicked, okay, the COM like this, like we have created previously. Let's put this one here, COM like this, and equal string as the string file function. Okay, and clicked again, so clicked COM will be set. So we'd like to set up this one, so for COMs of 0, so the first one should become 0. Okay, and now we can create the option menu. Let me go, it's exactly same as this one. Let's copy like this. Even I can copy all this at the same time and correct this one, by the way, bring it back to 0. Okay, so here I need to change some stuff. So it's not clicked BD anymore, but clicked COM. And we don't need the BD, but COMs here. Okay, that should be fine. And in this one, I have to change. It's not clicked BD, but let's call it like drop COM here, drop COM. Okay, and we would like to have the width 20, same, so we keep the consistency. And finally here too. Okay, but instead of having it in row 3, we would like it to have it in row 2. Okay, I think we should be good here. Let's check. Okay, and we run here. Okay, let's see. So we do have our ports, both of them. We can see the COM3 and we can see this one. That's really perfect. Okay, so now we need to check some stuff, and this time as you remember, let me bring back again the picture here of the window. The connect button is not is disabled, and one condition that we would like to make is, as far as this one is still not selected and this one is not selected, we keep just waiting for that. So let's take a look at that first of all. So let's create a new function. Let's call it a connect check, for example. Let's put it a little bit here, or even here, def connect check. Okay, and that we put some args as an input. Okay, and each time that what we would like to do exactly, so each time we select the menu, we select something, we have to call this function. So what we need to do is to add this part command, not command, but it should be small letters. So command is we will connect here check. Okay, so each time we do have this one, it will call the command check. Same for also this function for the drop here. Okay, and what we are going to do is quite simple. So first of all, we need to I'll correct this. We need to put global here, and some function have to be quite checked. So what we need to check first is this one. We are going to put it as a global, and also here the string var of clicked COM we are setting up as a global. Okay, so we can use them directly in the function. So we go back here and we do a condition. If this one is in, so clicked.com, this one dot get, so we are going to get what is selected, or this one is in the other one, which is clicked db. Okay, let's find it away. So this one is clicked db here. Okay, so then what we have to do is the connect. Okay, we need to put connect button as a global too. So where is connect button? This one, let's put it as a global here. Then connect button state. So this is how we are going to change the state. Okay, so if there is one of them is not selected, we keep it as a disable. Okay, and after that, else, if both are like selected, the connect button state will be active. Yeah, I made a mistake. I thought it was enabled, but it's active. Somehow the people who created that had a certain sense of humor. Okay, so let's take a look together what's going on. Okay, something here is not working, but we will check it here. Okay, that's a good thing. So argument type string var is not a terrible. Okay, let's check, of course, because I forgot, dot get. If I click here and run again. It's good to make mistakes, so we can here, and if I select something, it's connected. So, and if I select this one back, it's this, like the connect button is not working. That's wonderful. So now what we need to do and to add is to give this refresh button a certain power to refresh this menu each time something is happening. If I add a cable or remove it, I don't need to keep connecting again and again. So we already made most of the job, so let's close this one. So what we need to do is each time we enable, we generate a new one here just in case. So what we do, so this is the refresh button that we created. We can add a comment here, okay, and it will be equal simply to this function, the update COMs. Okay, so but however there is one thing that we need to do. If we create this one again, what will happen if we do like this again, what will happen is another option menu will be coming on top of this one, which we don't want at all. So what we need to do, so first we have to make a try here like this, and we call this drop.com here, we put it like this, and we put .destroy. Okay, and here the accept pass. So what will happen, so correct destroy. So what will happen, so for the first time, yeah, that will be, we do have a red line, but that should be fine because it's not declared yet. So if the first time is happening and it tries to destroy it, that there's no variable on that name, so the error will be generated and will continue normally here. But for the second time, if we already created that one, it will be destroyed and generate a new option menu with the updated data. So let's save this one and run the code and see what will go on. Okay, so we do have here COM3 and we select something, but if I run here, I do have this one, so that's not really, we need to see what will happen if we remove the cable. So let's make this one smaller. So now the cable is connected and I do have this two options. Okay, so let me remove the cable. Okay, so I still have this both, but let me refresh, and now I have only the option null. So but here still this one connected is not updated, so something is wrong and I need to confirm. But let's bring back this cable again and let's run. So it takes a little bit of time and that's perfect. Okay, so let's close this one and understand what's happening. So what did happen is we refreshed this one, but we still didn't run this function. Which one? This one, the connect check. So what we need to do is to go here at the end and add the connect check 0, like just to run the function without any issue. And let's go back again for our example. Here's the camera here. So now I have this COM and this one. So if I run my refresh, you see that immediately this one gets to 0 because I had to refresh and check, and this one has been disabled. So let's remove, let's select here, sorry, like this, let's remove the cable, and if I refresh, do not have any connect, cannot connect. So let's bring the cable back here, and if I refresh, it takes a little bit of time, and I do have my COM3 coming back again. Okay, so now we could create a user interface that dynamically select the COM, so you don't have to type it within the code and find it like the program will find it, and also you can select between the baud rate. So we are really ready to go to the next step now. So by completing the update of available COMs and Baud and putting a little bit of logic for the connection button, so now we can jump and go to take a look on how to have the serial connection set up. So this is where we stopped last time, and this is the picture that we do have. So as soon as we get this selection made, we can have access to the connect button. And what we would like to do before getting to the serial is to start having some logic when I click on the connect button. So when I click on connect, I would like to this one become disconnect, for example, and I will not be able to select this bottom anymore because I'm in connection mode, and that will not make sense to change dynamically this one during that time. Okay, so let's start and work on this one, and by doing so we would need to connect this. We'll create a new function, we call it diff connection. Let's put it here. Okay, so diff connection, let's put with the X, maybe it's correct, I'm not sure. And let's see, so first of all we will put only now the case of the logic of the GUI. So first of all, so if we need the connect button dot, like the not the option it or the text inside it, like this, is equal, or let's say not equal because it's a string, so we have to put in disconnect. So if it's disconnect, then what we have to do, we need to change the text of the button here. So this one will be equal to connect again, and also we need to freeze, or how to say, oh, this is actually if it's disconnect, so it means we went to the connection mode. So let's put here else. What we need to do is the opposite, so let's copy this one. Actually it's equal once, let's put this one, and this is here where we have to freeze everything. So this one is equal disconnect in this situation. Okay, let's have a quick test to see how things will go just for this one. Okay, let me bring the GUI, and let's go like this and then like this, and if I put connect, nothing is happening. Okay, so yeah, of course, because we have to connect some function when I click on this button. So let's go back, so let's copy this one like this, and if we go to the init menu and we go to our button here, and if I put on the connect button a command equal connection, sorry, and if we run it again, let me bring it here, let's select like this and put connect, we have the disconnect button. Now we have to manage to freeze all this when we are in the connection mode. Okay, so this one is flipping quite well. Let's go back and flip all the rest. So we do have the other button called, let's bring it here, refresh button. I think that will be quite straightforward and simple. So I will bring this one and just text equal, not disconnect, but it's actually status. Yeah, state and equal. So when we go from disconnect to connect mode, this one is this A is active, actually not disable. So same for the menu that we created here, the option menu, the one related to the baud rate, which is this one, the opdb, this one, and we just copy like this again. And also finally the last one, which is not the baud rate but the COMs, and that will be this one, the drop and debug COM here, and we bring it like this, and state will be active too. At the opposite, so let's copy this one here, and we should put this one like this. This one will be disable with a small d, disable like this, because the logic here is very simple. Let's put this one here and this one here. Okay, so let's take a look on how things are going on. So let's bring this one, come here, and if we select what's happening, we have an error, so because it's not defined, and this is we need to bring the global, put a global, so we do not have any issue with that. So let's bring the global stuff here, the refresh button also. Actually the clicked, we don't need it. This one, and this one too. Let's put them as a global. That should solve this issue. Okay, nope, not solved, because let's check. Yeah, because I have to put it global at their function level. This one here, and we said the refresh button is not global too, and also so this one also we need to bring the drop button, this one here. Let's check, and probably I don't need this one. Let me just comment it. Let's run it, open the window, and let's check quickly. So, and let's connect, and here we are. So each time I click connect, this button changed to disconnect, and I can't anymore select, everything is frozen. And then when I put disconnect, brilliant. So we could enter within kind of a pure serial mode. Okay, so now we went through that. So let's create few variable to input the data and start our serial connection. So port will be equal to the clicked, yeah, the clicked.com.get here, and baud will be equal, the baud without the e will be equal to clicked bd.get. Okay, just in case, let's print both to see how things are going, and baud. Okay, so we will print them. So let's put a clear here, and let's run it again. So as soon as we'll connect, we are sure that we do have the right data. Connect, yeah, we do have the data here, everything is going well. Okay, let's disconnect, close, and let's start reading then, like activating the serial data. So first we are going to try, because just in case if we get back we don't have any issue, ser or serial equals serial dot serial here, and then we put just baud and timeout equals 0. Okay, this is the function that will activate the serial function, and we'll start reading. Okay, except, so if there is an issue, you just pass. Okay, that's perfect. Here we start reading, as we initiate the reading, and we can start having a new function. We can call it I think read serial without any problem. It will be exactly same as the one we created here. If we go the animated one, so where is it? Something that they like this, my serial here, we call it read serial, just to change a bit the name. So def read serial here, and let's start. Okay, so first of all I need to add this here. So first of all we need to get, we are going to use this serial, so we need to put it as a global. So let's increment and put ser here, and bring, where is our serial function? Yeah, perfect. So what we need to do is, let's say, while, let's have create a serial data and put it as a global. So a global here, and we call serial data. Okay, so the serial data, which is also here, let's put it also inside the connection menu here. So if we are going to read the data, so we are leaving the disconnection mode, so serial serial data will be equal to false. Okay, and if we are reading in the reading mode, serial data should become true. Okay, so let's bring here like directly, let's put this one true like this, and this one put it at the beginning as initial condition. Okay, so while serial data, so if it's true, then we are going to start reading the data. So if serial data here, what we are going to check, so data will be equal, it's exactly same as we have wrote in the last time, so read line. So we are reading as we have discussed. So let me show you the one that we worked on. So let's check here. So this is the one. So we are sending a message, a simple message ending with an AND line. So each time the program will be finding a whole message ending with this /n, which is showing here the read line, it will say this is a whole message. Okay, so after that we have to check if the len, I don't need to add parentheses, so if the len of data is greater than 0. Okay, so if the len of data is greater than 0. So now we do have some data that makes sense. So what we are going to do, we call, for example, data sensor or data or sensor, whatever. For the moment, let's call it sensor. It will be equal int of data, we do the data, and we need to add a decode. We have to decode because the data that is coming from the microcontroller is a byte format, and we need to decode it to the UTF format. So let's put here UTF-8 to be more accurate. Okay, so that's what we need to read, and what we are going to do is just here print sensor. Okay, that should be simple and easy to go on. Okay, so let's quickly take a look on the microcontroller. So everything is good here. I will load the program again, just in case, not here, this one, and let me load the program and close both. So, and if I run this one here and bring this one like this and connect, I should be reading something, but nothing is happening. You know why? Simple. Let's close. Because I have to call this function the read serial here. Okay, so let's bring the read serial, each time read here. After doing all this, let's put the read serial, and we should see in the inside this one, inside the terminal, our data getting read. So let's save and save here and go again, bring our small GUI and putting this one like this and connect. So we do have, there's a problem here, there's something not working on. So let's check this one. UTF codec can decode byte. Okay, something is getting wrong. Let me check. Let's save, build and load. We should be good. So here, Control C, and let's check again. So what we can do, just to see if there's no error or there's no problem, let's put, probably because the first line of data that we are reading have a problem, what we can do is in the serial, here we are, instead of directly going this one, we can put a try like this and accept. That will be much easier, because sometimes the data, even with those conditions, is not properly passed, so that's not enough to manage the data and manage the exceptions. Pass. So let's try like this, and let's connect again. So I connected. So let me show you again, guys. So I'm sending the data using the 15,200 baud rate, and I'm using my UR2, but that's not an important one. And the the USB or the serial connection is the COM number 3. So if I connect now, you can see I have my data. So let me check in the camera. If I move this potentiometer, you can see the value is moving from 0 to 1000, which is exactly what I need. Okay, perfect. But you can see that's a big problem. My GUI is dead. So the reading the serial is killing my GUI. So let's close it here, close the program. And there is a workaround for this one, because there's a problem now. What we can do, so we have to add the nice and very helpful threading library. So import threading. I think it's a very good example for using threading. So, and what we can do is not calling the function here just like this, but we create a thread and we use it to run the function inside the thread. So let's go again and put T1 equal threading dot thread, and we put a target. So this is the function that we would like to read in a different thread, and we call it the read serial. Then let's put for the thread, just in case, a daemon. Just if there's any issue, this thread will be like relieved or stopped. It's not the cleanest way, but that's a very easy and fast way to do it. So if there's any problem or the main program stops, this thread will stop anyway. And finally, T1 start. Okay, so now let's see the difference at what will happen. Okay, so this is our window or GUI. So connecting, and let's connect now. Okay, so nothing is happening. Why? So the GUI is working properly, but let's close here. Let's check what is going on. So we are putting the thread in the target. Here it's serial daemon. Okay, let's print something just in case. Print thread start. Okay, so and let's run again. Okay, let's bring this one here, come and this one and connect. So it doesn't even go for the thread. So let's check what's going on here. So except, so threading thread target equal read serial. So the function is a read serial. That's correct. Let's copy paste just in case. Okay, let's try to run again. I maybe made a typo, so this is sometimes happening, you know, when you do stuff live and nothing is running. So even this message that I'm printing is not going on. So something here is blocking everything. So what I will do, sometimes this happen, I will kill this terminal and let me run again in terminal. So let's go here, Python, and we are at 003. Okay, so let's check. Sometimes terminal have an issue, so connect. No, it's not working. And why this is not happening? So let's check again step by step. So we imported threading. Let's go back. We do have threading, that's correct. And then yeah, of course that's an obvious. So I forget the parentheses. Yeah, the live matters. Yeah, and life also matters, of course. Okay, let's connect, and that's working. And you can see now I can, like, it's not dead. I can go back and rerun without having any issue, and my main thread related to the window is working perfectly. So good. So now we finished this step and ready to go for the next one. We have set up the serial communication and we could have access to the data using the GUI. So now the next step, and the logical one, is to have a dynamic GUI update using the same serial data. So we're almost there. We created the GUI, we are reading the serial data. Now let's have it dynamic and let's start creating this animation. Okay, so we stopped here and we need to have some animation here with like a simple one at the beginning, and then we can explore further in next courses. Okay, so let's close this and go to gem. So when we speak about animation in Tkinter, we have to talk about canvas, and then let's create some canvas to work with. So before creating the canvas, I would like, as we will need to manage a lot of animation or a lot of element inside the canvas, I would like to create a small object. So I'll call def, not def, actually it will be a class. We call it graphics, and this one, we just empty one, we just put everything inside it to create and add our canvas and to make the transportability of this object quite easy. Okay, so let's start, and let's call it graph equal graphics. Okay, so this is our class, and let's start. First step, the first thing that we have to do is to create our main canvas, and this is the one that we will have inside it the animation. So let's put graph here. It will be equal to actually graph.canvas. Okay, and that will be equal canvas. So here where we are using the Tkinter library, so ender root, and let's say the width will be 300, so DTH always here 300, and after that height equal also 300. Then let's keep it like this for the moment and put the graph.canvas.grid here, that grid, and we are putting it row 5, so at the end of our animation, and we are going to use this time not the column but column span, so this will be extended to 5 column equivalent. Okay, column span equal 5. Okay, let's save. So where are we? Here, I think we are good, and let's run our program again, and we do have a problem. So column, yep, this is should, I forget an N. Okay, and let's run it here, and we do have our canvas. You see this gray array. So let's change the background, as you can see, so it's a BG equal white to have an harmonized color. Okay, so this is now we created where we are going to play with our animation. So the animation will be one circle, actually it's 2 circles, one outer circle that we will be moving depends on the value of the output, and the inner circle that we will show the value. So let's start with the outer circle. So let's go for graph dot here outer. You can name it in a better way. I think I'm very bad at naming things. So it will be graph.canvas, or we are inside the canvas that we would like to have, and we will put graph.canvas, and here we are going to create an arc. That will be an arc of a circle that will be moving dynamically. And for this arc, so I will put a few numbers. So let's 10 and 10. This is the X and Y positions on the top left. And after that, I will add 290, another 290, and this is the X and Y position at the bottom right. Okay, so after that, we are going to say we would like to start at the 90 degree. So this is as an arc of a circle, and we would like to extend here like this, equal 100. And this is more like where I'm coming when I'm starting from. Okay, so let's do like this, and let's see what will be the result. Okay, let's run it. Okay, something is wrong, so extend is not correct. Probably my English is always making some default. I'm betrayed by my English. Let's check here. Yep. Great, we do have our arc of circle taking this position, but somehow we need to add some colors, and let's start doing that. Okay, let's close this, and we need also to change a little bit the thickness of the canvas, because we still have that kind of line. So we can put, it's a long word, and usually I make a mistake on it. It's highlight like this, and then thickness like this, and equals 0. I hope I made it correct, because I'm usually making wrong. Yeah, that's correct. So you can see here I do not have any more an array, and that looks quite free inside the whole GUI. Okay, so let's change here the color of our arc. So let's put the outline, so everything will be red, and feel free to change the color you want. So I had to make some research, but usually it will be the F, and actually not F, it will be the hexadecimal number for the color, and it's dash F11. And also same thing for the fill, it will be the same color, equal the dash 11. Feel free to do the color you want. I'm quite lacking some, how to say, artistic knowledge, so excuse me for that. Okay, and the width I will put 2 for the fill. So we should be good, and we should see some red colors. Here we are, this is our color here, and this is the animation or the arc that will be moving based on our value. Okay, great. So let's go and jump to the next one, which we are going to create the inner one. So this one, the graph inner here, and the graph inner will be equal. So this is where we create the, actually we don't even need to put some value here, because this circle will not really change a lot. So we can directly use graph.canvas here directly, and we are going to create just a circle on this one. So let's start creating it, and create here, and it will be oval. Okay, and it's a smaller circle inside the big one, and that we will do here. So it will be data, so no data, actually it's wrong, it will be a smaller one, so 75. It's still the same logic. It's like the circle is inside an array, and we are taking the top left array, and this is the X and Y of the top array, and the other two one will be the top the down right position, so 225 and 225. So we are quickly going to put the same stuff, outline and fill, and here that we are going to put, so if we go here, we keep the fill with red, but the outline will be white. And I think for the width we can put 2 or 3. That's not a big problem here. So let's check, and we should be good. Let's see here. Actually, yeah, we are not good. It's the opposite somehow. Let's change the fill, should be white. And let's move stuff before. Okay, and we put the F11 like this here. Yeah, this is the days where, yep, and we do have a very beautiful inner circle that we will put inside the value. Okay, now the other data, so I will put some comment just to make more sense. So for this outer one, it's a dynamic. Let's put here, sorry, control, so dynamic update for this one. The just the oval, this one will be just a static. We don't need, it's a static update, so we don't need it. Okay, and finally we need to have another dynamic update for the text. So this is also a dynamic update, and that's why we need to put it inside also, because we need to transport it, we will put it in the object. Okay, here, and so this, no, it's actually graph dot, we can call it text. We don't need to be very complicated, and we will have, as usual, the graph dot canvas. Okay, and what we can do is just create text. Okay, so as usual, we are going to put, so this is creating text, is just the X and Y where we are going to start. So what we are going to do, we are putting 150. I know it because there is a lot of experience in that. Another 150, and this is where we would like to put it in the middle, just in the middle of the canvas, and then we would like to anchor it. Okay, not anchor, it will be small letters. Anchor will be equal to, let's put E, so means that we would like to put this one at the east of the text, not the west. And for the font here, this is a good one to you can change the font of this text. So you have to put, I'll try to test my vocabulary, Helvetica. I hope this is correct. Okay, and then 20 for the size. We will experiment later on. Finally, and most important, the text will be initially equal to 3 dashes, just in case. Okay, so let's go here, run it. Okay, there is a problem. 20 have a problem. Somehow I made a mistake. Font equal this. Okay, something is wrong. Yep, that should correct it now. Let's try. Okay, has not. Okay, canvas does not have create text because we have to put create with an E. Okay, let's run it again, and here we are. Perfect. So what we need to add now, and quite simple, it will be something that will be static, and so not an update. There's no static update. It is just a dynamic for the other one. We're going to copy the same stuff here without putting something we don't need to put, and to transport within the with the class. So here we are going to create a text. We are going to put it a little bit more to the right, here 175, and after that, so here should be just millivolt, because we would like to display our data in millivolt. Okay, I think we are good. So one last thing, let's put graph as here as kind of how to say it, a global value, and we can start updating the data or creating something with a serial function. So now we do have everything here. So let's save and take a look before we jump later on, and we don't have some mess. And we do have some mess actually. You see that the position is not really as we want, and let's check why. Okay, so now we will understand the anchor. What is the meaning of the anchor one? So let's, if I go here and I put anchor east, but I would like to put it as a center. Okay, that will be more correct now. Let's take a look. Perfect. So now this value will be updated, and millivolt will stay stable. Okay, good. So let's jump now and start updating the serial read data. So we are going to get inspired from the previous data that we created in the animated terminal. So we are going to take the same stuff here. We would like to take the sampling and average and work with this one to, let's take here sampling average, and also the same logic here. So we will take a data sensor and we are going to read. So we are taking up to here like this, and after that, so not even empty bar up to here. Okay, we should be good. So let's go here, and if data, so we are not going to print sensor for the moment, and we are going to do like this. So it's exactly, so we are going to if you didn't see the previous program, so what we are the previous tutorial actually, so the idea is to read like a certain, like sampling, or read a certain time of data and provide an average that will show less, how to say, disturbance in the code. So this is one of the things that we are going to create. And let's create a small function, or let's directly use this one here. So we don't need to, let's print sensor to see. Let's print sensor to see how, if the program is working or not for the moment. So let's here work with this one. We're still seeing it, we will see it in the terminal. So I come, and here let me just run again and connect. So thread start, but there is no data feeding. Yeah, that's the feeding now. So let me show you the camera again. So if I change this one like this, we should see some changing. Okay, and just to let you know, in the tutorial where we created the code to read the ADC data, we made it from 0 to 1000, so we can have a roundup value. It's easy one to understand, but yeah, that's good. Okay, so the code is working, and we do have a good averaging. So let's close. Okay, that's a big problem. Control C. Let's kill this one. And so yeah, that's one of the thing, you have to disconnect before you keep this one, else there will be an issue. So it will be restart. Yeah, we are back. I think the program needed a little bit time to restart, so let's connect here. Okay, disconnect, connect again, like always, to disconnect before. Okay, so now we can jump and start updating our data. So what we can do is comment this one for the moment, and we just come here and try to update the graph that we do have. So we have graph.canvas. Okay, so this is the first one, and what we need to do is item config. I hope I'm writing it correctly, and that will be, so what we are going to update is a graph here, and the outer like this. So let's, I think I need to add as a global here a graph just in case. Okay, outer, so this is the outer circle, and what we would like to do is the extend will be equal the integer of 359 multiplied by, so what we need to do is a graph here dot sensor, and we are not even sensor, so this is something we are putting in the later on, but sensor and the whole divided by 1000. Okay, we should be good on this one, so let's save. I hope that will be working. So let's clear here and run this one again. Okay, we do have the data here, so let's go and select the options, and you can see, so let me show you the where is it? I closed the camera, so let me open the camera here. Okay, so you can see it's because I'm having a small value of sampling. And also another issue, so let's move this one like a little bit, so you see something is happening. One of the big problem that we do have here is, like, even I'm moving, let me take this one. Okay, what's going on? Okay, something, okay, now it's fine. So I'll be moving this, and you can see it's moving with it. Okay, but everything is frozen. So let's correct this one. So what we need to do on this one is to put everything in a function and then run it again. So let's put this one here. Okay, it's freezing again because I didn't close my program, and that's quite a big issue. Better to take the same logic from this one here in closing and to crash the, so let's take exactly same. So we take signal here, the signal will generate, so if I put at the beginning just signal here, and we go back here again, where is my signal? This is a part of the previous program we used to crash if there's like an issue like this one, or to clearly remove it. Okay, like this. So we are going to take signal, and then not my serial, not my thread, signal handler, system exit. Yeah, so if there is any problem, it will exit the system, but I need to put it somewhere else. Yeah, this one first. Exactly. So here, in case of there's an interrupt or a problem happening, it will exit the system. Simple. Okay, so let's close this one and go back here. Let's open a new one and try to test it. It's very annoying actually. So Python here and 003, this one. Okay, let's make a test and see how things goes. Here and here, you see this kind of problem you can find live, and sometimes. So now that's moving, so I'm moving now my potentiometer. Let me show you. Yeah, I'm moving the potentiometer and the graph is moving, but at the same time it's quite heavy, and we are going to fix this one at the same time, but just to show you what kind of problem you find if you put directly such a strong loop of the graph inside the main loop. So let's try to disconnect wherever. I think it will be quite hard to do that. Okay, it was possible, but let's go back here and close this one and see if it will. Now it's still quite frozen. I think that's a problem I have to think about. I killed the terminal. Okay, let's go back. So this is of course I didn't save. That's why. So let's go back again. So Python and then 003, we go back here, and 3 and this one. So let's connect and let's try to close. Okay, put in Control C still, but I think this time the terminal is not crashing, which is good, and actually the VS is not crashing also. So Python and 003. Okay, let's go back to our main program. So to avoid this kind of issue, what we are going to do is to create another function, def here, and we call it graph control, for example, graph control, and we are going to pass it like kind of a graph. Let's call it graph, simple. Okay, and inside this one we are going to take this and Control X and take it here. Okay, so and after that we are going to create another threading. So let's go, where's the threading? We can create it again. So T2 equal threading dot thread. Okay, and what our target is, so target is equal to the graph control here like this, and also we need to put some arguments, args equal, we put the graph. Okay, and here to transport the whole thing we put just graph dot sensor will be equal to sensor. Okay, so after that we have t2 dot daemon. Let's write it correctly. Daemon equal true, so means if the system crash, this should be stopped anyway. And also t2 dot start. Okay, so we should be good now. So threading, something is wrong. Emulate subset of Java. Surely the mistake is really obvious and stupid. So instead of args, I wrote something that I can pronounce. Okay, that's good. So now everything is good. So now we have to go back here and put graph.sensor here and put a dot like this. So let's check. And also we have to indent this one to be under the if, so it works in the correct way. Okay, so let's run this code and see what will go on. Okay, and after that going to this and connect. So let's move. It's moving quite very smooth, better than before, and you can see I have really much easier control. So let's show you here. So I'm moving it and it moves so smooth and so much better. Okay, so by putting in a different thread, now the data is much easier to control. Okay, so let's disconnect and let's close. I can see it's working perfectly. So but let's go back also and see what would happen if I go here. So now that we fixed that issue and we go to this one, we connect, so it's reading, and if we close we still have some issue, but we can have the control C, or okay, we see that there is the main loop is going on, so we still have that issue that we need to close it if there's a problem. Okay, so the system has crashed again, but this is coming from this loop, so we need to find a way to more work on it. And this is maybe something else for the next episode, but still you have to disconnect so there is no issue. Okay, let's confirm again. Okay, so we are back again. So we are back again, and we need just to now update the numbers that we would like to see inside. So we do exactly same stuff here. Let's put this one in this here, and instead of the graph outer, what that we will change is just a text like this, and instead of this one, so we need to, instead of extend, we will put text equal, and that will be, we can put all this stuff here inside just parentheses, and then put it like this and add an F here. Okay, so that should be really good, and we can multiply the whole thing after we divide. So we don't need to do this one, but the data that we got from the divided by 1000 and multiply by 3.3 to see how many millivolt we are reading. So let's run this one and see what will be the results. So let me show you also the camera. Okay, so let's connect. Go to this one, connect here, and let's work on this. So we still have a 0. So even though this one is correct, this is wrong. So let's disconnect and close to see what's going on, why this is showing as a 0. Probably because I'm not multiplying by the right thing. So yeah, that which should be normal. So I'm putting int. So I'm dividing this one by 1000, and I should multiply inside. Okay, so we bring this one here and we just multiply. We don't need to divide by 1000. That's quite simple. Yep. And let's take a look again here and here. So you see we do now have a real menu and we have a number. So let's take a look how our value increases. The more the value increases, the more I do have red, and then when I turn in the other side, I have a very easy and simple to see graphic user interface. So we almost complete everything, and we are going to go to the next step, which is finally find a debug for the way where we close suddenly and we don't know how to deal with this one. Stay tuned. So we are getting at the end. We have the reading, we have the serial data displayed dynamically in our GUI, and we still have one last step, is to clear out the serial issue that we had when we close suddenly the window. So let's stay tuned and have a quick fix for this one. We are at the end of our program and we still have only one issue. That issue is if we close that window, not by closing the connection, the terminal kept frozen. It's not a big issue at the end, but we have to deliver a clean program. So what we can do, and this is the last step and easy one, so we come here and what we can add is to have a root.protocol. Okay, and there is a special code that we have to add, and that's this one. So wm delete window, okay, like this, and we had a function, let's call it close window. Okay, so inside this function what we have to add, let's go here and define close window like this, and the first step is we are going to do is we have to make a global, and let's add the root, and also if we go to serial, let's take serial data. Okay, serial data. So what we will put, serial data will equal to false, and this will immediately stop the function, and after that we have to add the root.destroy. So we are destroying the whole root. Okay, so let's go to the Python, and after that 003, let's start reading. So let me also put the webcam just in case, and let's go for COM3, the baud rate, and we start reading. Working perfectly, no issue at all. So we are turning, and suddenly we would like to close, and here we are. Our program, we went back to our terminal, there is no issue. So let's close everything. So we went through, it was a bit of a heavy manual, we went through everything. So let's open it again to see, because it's really beautiful and satisfying. So let's put in here COM, and this one connect the video. So you do have a dynamic update, also a very smooth one, because we mitigated the issue that there's one thread working on the loop of the main GUI, and you can see that's going quite well, quite smooth, even with a very small sampling. I hope you enjoyed this tutorial, and see you tuned for the next one.